In the previous video, we have seen how to convert a complex number from Cartesian form to polar form. We have already discussed what is polar form of a complex number. Here in this video, we are going to discuss working rules for converting z is equal to x plus iy to polar form. Correct? So this is complex plane x dash o x, this is x axis, and y o y dash, this is y axis. Correct? So let z is equal to x plus iy be the complex number. Be the complex number in Cartesian form, and in polar form we know z is equal to r cos theta plus I sin theta. When we compare these two values of z, then x is equal to r cos theta and y is equal to r sin theta. If P is any point here, P is any point having coordinates x, y, then this point P will represent complex number z is equal to x plus iy. And if we take coordinate of P r theta, then this is polar form. R theta are polar coordinates respective to this complex number z. So we can convert a complex number from Cartesian form to polar form when we evaluate the value of r and theta. By finding these two values r and theta, we can simply put values of r and theta here in this expression and we can get polar form of this complex number. Here we are going to discuss how to get these two values r and theta. Okay, suppose this is equation number 1 and this is equation number 2. So by squaring and adding these two equations, by squaring and adding, we will get r square cos square theta plus sin square theta. This is equal to x square plus y square. And as we know, sin square theta plus cos square theta is equal to 1. So therefore, r square is equal to x square plus y square. And r is equal to square root of x square plus y square. This is, we have to take only positive value because r is the distance of this point from origin. So we have to take this positive value. So by this formula, r is equal to root over x square plus y square, we can get value of r. Okay. Now we have to find value of theta. So there will be three different cases for finding the value of theta. If z is purely real, case 1, if complex number z is purely real, then z lies on x-axis. Then z lies on x-axis. Correct? So in this case, if x is greater than 0, then theta is equal to 0. Purely real means z is lying somewhere along x-axis in the positive part of the x-axis. So if x is greater than 0 means x is lying point p, or you can say complex number, is lying in the right side of origin, right side of pole, then if x is greater than 0, then theta is equal to 0. And second case, if z is purely real but x is less than 0, then theta is equal to pi, correct? And if z is purely imaginary, third case, if z is purely imaginary, what does it mean? It means z is lying along y-axis. Then z lies along y-axis. So here, if y is greater than 0, theta is equal to pi by 2, and when y is less than 0, then theta is equal to minus pi by 2, correct? So in this way we can decide the value of theta, and if you find value of theta, now we can put the values of r and theta here, and we can get the complex number z in polar form. When z lies in first quadrant, theta is greater than 0 and less than pi by 2. If z lies in the second quadrant, theta is greater than 90 and less than pi. If z is lying in the third quadrant, then theta is greater than pi and less than 3 pi by 2. And if z lies in the fourth quadrant, then theta is greater than 3 pi by 2 but less than 2 pi. So this is the method, this is the process for finding the value of r and theta, and by getting these values we can convert a complex number z in Cartesian form to this form, polar form. Hope you have understood it, and in the next video we'll see some important questions. So remain in touch and share this video with your friends also. Wish you all the best.